We're going to learn about the decorator pattern in this module. This pattern allows adding behavior dynamically to an individual object without affecting the behavior of other instances of the same class. It's sometimes referred to as a wrapper, which is something the adapter is also sometimes referred to as. I'm Kevin, and I'll guide you through this module. We'll start the module by describing the decorator pattern. We will learn what it is and which problem it solves. The real-life scenario we will cover while doing so is related to collecting statistics and storing a list of sent email messages. From that real-life sample, we will learn about the pattern structure and will implement it. After that, we will cover the pattern use cases, consequences, and related patterns. Let's start with describing the decorator pattern. The decorator pattern is a commonly used structural pattern from the well-known Gang of Four design patterns. The intent of the pattern is to attach additional responsibilities to an object dynamically. A decorator thus provides a flexible alternative to subclassing for extending functionality. Just like the adapter pattern, this pattern is sometimes called a wrapper. Attaching additional responsibility or behavior to a class can easily be done by simply adding an additional method to the class. In this case, however, we need a way to attach additional responsibility to an object and not to a class. We want to allow this dynamically, so at runtime. That's a bit more complicated, but not that much really. The fact that this pattern is sometimes called a wrapper should already give you a good idea of how something like this can be implemented. Let's clarify this with a real-life example. In one of my other courses, I use a cloud mail service and a regular on-premise mail service to send mail. Both of these implement a simple iMail service interface, which exposes one method, send mail. Now imagine I want to add some functionality to this service. Say that I want to start collecting some statistics. For example, how long does it take sending a mail? Or how often is the send mail method accessed? I could add that functionality to the different mail service implementations, but that violates the single responsibility principle for that class. Moreover, imagine that I want to add even more responsibilities, like logging when a mail is being sent or storing all the sent mail messages in a database somewhere. Our classes would get littered with code that doesn't belong there. And that's where the decorator pattern comes in. Let's start with our iMail service and both implementing classes. We're going to create a wrapper around our iMail service to add the functionality we need by overriding the sendMail method in that wrapper. We can call that wrapper mail service decorator base, for example. It's an abstract base class, which also implements the iMail service interface, thus exposing a sendMail method. Next to that, we also store the iMail service instance we want to decorate in this decorator. It's now up to concrete implementations of the decorator to effectively add functionality. We could have a statistics decorator that derives from mail service decorator base, calculates some statistics and then calls into the sendMail method. We could have a message database decorator which stores all the messages that are being sent in a database, and so on. Instead of directly calling, for example, cloudmailservice.sendmail, we can now call statisticsdecorator.sendmail or messagedatabasedecorator.sendmail. So with a few simple interventions, we can easily extend the functionality of the mail service objects without having to resort to an explosion of subclasses or large inheritance trees, and while at the same time sticking to the single responsibility principle. That's pretty cool, right? From this real-world example, we can now extract the structure of this pattern. The iMail service interface structurally is called a component. The component defines the interface for objects that can have responsibilities added to them dynamically. Concrete implementations like our cloud mail service and on-premise mail service classes are called concrete components. Concrete component 1 and concrete component 2, for example. They define an object to which additional responsibilities can be attached. The other implementation of that iMail service interface, or of that component in this case, is structurally called the decorator. That's our abstract mail service decorator base class. It intercepts, if you want, the send mail operation, thus allowing us to extend the functionality of the object. It maintains a reference to a component object and defines an interface that conforms to the component's interface. Concrete implementations like statistics decorator and message database decorator, which contain added behavior like storing statistics and/or added state like a mail message store, are called concrete decorators. For example, concrete decorator 1 and concrete decorator 2. They are responsible for adding responsibilities to the component. And like that, we know how the decorator pattern is structured. Let's implement our real-world example. In this demo, we will implement the decorator pattern. Let's start by adding our component, the iMail service interface. Note that as with many of these patterns, this can also be implemented with an abstract class instead of an interface. Our interface contains one method, sendMail, accepting the message to send. It returns a boolean, so we know whether sending the mail was successful or not. Then we can create our concrete components. We do that by implementing the interface. In the first concrete component implementation, named Cloud Mail Service, we fake sending the mail via a cloud service. And we do something likewise with an on-premise mail service, another concrete component implementation. So far, so good. Up next is the decorator itself. Let's add a new class, Mail Service Decorator Base. This will become our decorator. As we learn on the slides, it should implement the iMail service interface. Like that, we ensure that the same method, sendMail, must be implemented. We'll get to the implementation of this method immediately. First, we ensure that this class can only be constructed with the iMail service implementing object being passed in. That is the object we want to add functionality to. We store that in a private read-only field. We do still need to call sendMail on it, and that's what we do in the sendMail method on our mail service decorator base. And we return the result. But this isn't done yet. This class doesn't really do anything yet. It wraps the iMail service, but it doesn't add functionality to the mail service. This serves as an abstract class to store the iMail service instance. You could name this a base wrapper. We don't want this to be used on its own, so we mark it as abstract. One thing left here. We want to make sure we mark the sendMail method as virtual, so implementing classes can effectively override this and add functionality. And that's it for this class. Now let's add the concrete decorator implementations. The first one is a statistics decorator. It implements the mail service decorator base abstract class, which ensures that we get a constructor generated. We call into that base constructor from the statistics decorator constructor. Like that, our mail service is nicely stored in the private field. We also override the sendMail method. We collect some statistics and we send the mail. We have to call base.sendMail for that, as the actual implementation of sending that mail is at that level. On to our second concrete decorator. Our message database decorator. Likewise, it implements the mail service decorator base. It stores a list of sent messages, acting as a data store for messages sent through this decorator. In the sendMail method, we store the message if it's been successfully sent. And that's it for our pattern implementation. Let's test this. The first thing we want to do is instantiate our mail services. For that, we need to import the decorator namespace. So we new up a cloud mail service and an on-premise mail service, and for testing purposes, we send a mail through them. That's the default behavior of these mail services. What we want to do now is add behavior to it, to collect statistics. To do that, we decorate the cloud mail service, for example, with a statistics decorator. And then we send the mail through that statistics decorator. This should show us some added behavior, in other words, some added functionality. And then we also add behavior to the on-premise mail service. As you can see, this works in a likewise manner. The decorators work on the mail service interfaces and not on the concrete implementations. So we send a few messages through the message database decorator, and then we run through the stored messages to see whether or not our decorator successfully executed. Let me add a read key statement here, and let's give this a try. And there we go. The first thing we see are the two messages we sent via the send mail method on the services themselves. Then we decorated one of them with a statistics decorator. And that's what we see next, collecting statistics in statistics decorator. So we pass through that. The next line is the message passed through to the cloud mail service from the statistics decorator. Hi there via statistics decorator wrapper. Up next, we used the message database decorator to send messages via the on-premise mail service. We did that twice, which is what you can see on screen. After that, we ran through the stored messages, because the message database decorator stores the messages that are sent through it. And we indeed see our two messages being sent. With that, we successfully implemented a decorator. Let's have a look at the use cases for this pattern next.